Hello guys, welcome to today's tutorial in Economic Workshop. Today's tutorial is the continuation of the topic, optimization of economic function. Kindly visit the previous tutorial if you haven't, because we would be using the knowledge from the previous tutorial on how to optimize an economic function. In this tutorial, we would learn about marginal concept and optimizing economic function.
Marginal concept. The concept of marginal implies the rate of change of a variable as a result of change in another variable. Examples of marginal concept in economics are marginal cost, MC, marginal revenue, MR, MPS, which stands for marginal propensity to save, MPC, marginal propensity to consume, MRTS, marginal rate of technical substitution, among others. Marginal cost, this is the change in total cost, TC, as a result of additional unit of production. Given TC is a function of Q, MC is derived by differentiating TC with respect to Q, that is MC is equal to the TC the Q. Mathematically, given TC equal to 4Q raised to power 2 plus 7Q plus 2, to get MC is by differentiating TC with respect to Q, that is MC is equal to the TC the Q, which equals to 8Q plus 7. Marginal revenue is the change in total revenue, TR, as a result of sale of an extra quantity of a product. It is derived by differentiating the total revenue with respect to quantity of the product. That is, given that TR is a function of Q, MC is equal to the TR the Q. Example, given the demand function P equal to 30 minus 2Q, find MR. To get MR, we need total revenue function, which can be gotten by multiplying the demand function by Q, that is P multiplied by Q, therefore TR equal to 30 minus 2Q multiplied by Q, which equal to 30Q minus 2Q raised to the power of 2. To get MR, differentiate TR with respect to Q, that is MR equal to the TR the Q, which equal to 30 minus 4Q. Optimizing economic function. Example 1. Maximize the following total revenue and total profit function. Given TR equal to 40Q minus Q raised to the power of 2. Kindly take note of the steps in optimization of economic function from the previous tutorial. Step 1. Take the first derivative, set it equals to 0, then solve for the critical value, that is the TR the Q equals to 40 minus 2Q equal to 0. 2Q equal to 40. Q equals to 20, which is the critical value. Step 2. Take the second derivative and evaluate at the critical value to test for relative maximum or relative minimum. Note, for this problem we are testing if TR is truly maximum. The TR square the Q square, which represents the second derivative, equal to minus 2. The decision rule is the second derivative evaluated at the critical value resulting to a negative value that is less than 0 implies the function is truly maximized at the critical value. In this case TR is maximized, therefore substitute the critical value, that is Q equal to 20, in the total revenue function 40Q minus Q raised to the power of 2. Therefore TR equal to 40 multiplied by 20 minus 20 raised to the power of 2, which equals to 800 minus 400. The maximum total revenue is 400 while maximum quantity is 20. Example 2. Given pi, which represents profit, equal to minus Q raised to the power of 3 minus 6Q raised to the power of 2 plus 1440Q. Pi prime equal to minus 3Q raised to the power of 2 minus 12Q plus 1440 equal to 0. Solve the quadratic equation minus 3Q raised to the power of 2 minus 12P plus 1440 equal to 0. Solving the equation result to Q equal to 20, Q equal to minus 24. We have two critical values. Take the second derivative and evaluate at the critical values to test for relative maximum or minimum. Pi prime prime equal to minus 6q minus 12. Pi prime prime evaluated at 20 equal to minus 132, which implies relative maximum. Pi prime prime evaluated at minus 24 gives 132, which implies relative minimum. Note negative critical values has no economic importance, therefore should be ignored. Substitute the positive critical value into the profit function to get the maximum profit. That is pi equal to minus 20 raised to the power of 3 minus 6 multiplied by 20 raised to the power of 2 plus 1400 multiplied by 20, which equal to 17,600. The maximum profit is 17,600 and the maximum quantity is 20. Example 3. Optimize the total cost function. Note to optimize implies either to minimize or to maximize. Given Tc equal to q raised to the power of 2 minus 60q plus 1800. Take the first derivative, set it equals to 0 and solve for the critical value. Tc prime equal to 2q minus 60 equal to 0. 2q equal to 60, q equal to 30, which is the critical value. Take the second derivative and evaluate at the critical value. Taking the second derivative result to Tc prime prime equal to 2. The second derivative is a positive number which is greater than 0, this indicates the function is at relative minimum. Substitute the critical value into the total cost function Tc equal to q raised to the power of 2 minus 60q plus 1800 to get the minimum total cost, that is Tc equal to 30 raised to the power of 2 minutes 60 multiplied by 30 plus 1800. The minimum cost equal to 900 and the minimum quantity is 30.